Hello everyone, good morning. I'm Peter Kelecsényi. I will present you the new solution of Robustel called Edge2Cloud. I will explain what E2C is about, what is it for. Some words about our company first. We are CAD Communication Systems, a more than 30 years old company. We deliver cellular communication solutions for IoT market, working as a value-added distributor of several leading suppliers and providing engineering services for the market, like technical support, custom development, consultation, and product customization. Robustel is our partner. We represent them for more than 12 years in our region. Robustel designs, develops, and manufactures industrial-grade IoT routers and gateways for the global market. They also offer services and end-to-end solutions for vertical markets. As Kern, our main markets are industrial automation, IT backup, video surveillance, utilities, transportation, security, and honestly, we can deliver solution for any IoT verticals. What is our product? Our product is a communication device which is connected to an end device via a local interface and protocol and transmits the field data to a remote location. Here you can see the layers of IoT and you can see what we offer for you. We have field routers and gateways and applications running on them. Which supports a very wide variety of protocols and interfaces. Then we have management service to provide managed communication, offering high reliability data transmission. So these are the layers that we offer for IoT. E2C is an application which runs on a field gateway. What is it about? How can I explain it in 2 sentences? E2C collects the field data and uploads it to a cloud platform without any line of coding. It's very simple and very comfortable, and it's working like a plug-and-play application. Where it's coming from is a very long story. Several modules of E2C already exist on the market for years, so we already offer it to our customers for a long time, like Modbus RTU, TCP, was available as an application. IO port handling was the part of the operating system of the devices. On the other side, we already have Cumulocity, ThingsWorks, and other platform integrations. But usually these solutions was made on a project basis, not as a general feature of the router. What E2C is the integration of existing local and WAN communication modules and features in one framework. E2C is more than a simple integration of the modules. It's a framework which offers the possibility of being extended by new protocol stacks and platform integration. And E2C has a clear roadmap about the future integrations. So it's honestly a very nice looking future. Like the story of E2C, what is the reason that the modules existed for a long time but are integrated only today? The reason can be the cloud platform evolution. They became secure and stable for today and can be accepted by industrial and the IoT customers. I think 10 years ago, none of the companies could imagine and allow to store their sensitive data externally outside the company walls. It has been changed. First, the IT industry accepted cloud technology, virtual machines, servers years ago. And for today, the industrial companies are more open for such applications. If you take a look on the leading cloud solution providers for IoT, they are the same like the suppliers for IT, like Oracle, IBM, Amazon, Microsoft. They bring the cloud platforms to the IoT and bringing the protocols like MQTT and, of course, the very high level of security. Okay. Let's dig deeper in E2C. What is it in details? Is it an application or a solution? Is it more a framework which gets together the local interfaces and protocols which are used in IoT and the communication of cloud platform which used globally? The E2C framework collects the field information from a PLC, data loggers, sensors, and transfers them to a JSON format, which can be easily integrated to the cloud. E2C doing this without the need of any coding. Very simple, very comfortable. It's a plug and play solution. This kind of stuff was much more complicated for the customers before. It can sound unbelievable, but it's reality. No need to code anything. It's done. You only need to configure everything on the user interface of the router. This is a typical E2C system architecture. On the left-hand side, you can find the sensors, which are connected to R1520 via serial interface and the Modbus protocol. Then E2C transform it to JSON and transmit it to a server platform via MQTT. All the data collection, protocol conversion, and cloud integration is running on the router. No need for any external controller or a field PC. All of the features are supported by the LTE router, which is a very cost and size-effective solution. We can save the cost of the controller. The size of the application is smaller. Integration level is higher than it was before. So the final solution can be more integrated in terms of hardware and software. It's pretty good. Robustel has a very wide variety of industrial devices, and all of them are powered by Robustel OS. It's an operating system developed by Robustel. And thanks for the same operating system, the applications can run on almost all hardware devices. It's true for E2C too, but there are some specific devices which is suggested to use for E2C applications. These are R2110, R3000, and R1520. They have plenty of physical interfaces and processing power to serve E2C correctly. They have powerful CPU, they have enough memory, and they have a lot of interfaces, serial, Ethernet, digital, analog. So these are the best products for an E2C application. Okay, then let's see where we can find E2C in the router. There's the graphical user interface of the router. If E2C is installed on a router, then you can find an Edge2Cloud menu section in the left-hand side menu. If you open it, then you will see all the modules which are or the E2C modules which are installed on the specific router. Let's see E2C modules one by one. Starting with the southbound applications. The southbound applications provides the local communication protocols via the local hardware interfaces. The interfaces can be I/O ports, Ethernet, RS232, RS485, or Bluetooth in the future. In case of R1520, we support analog input too. And we support a Modbus TCP, Modbus RTU, and router I/O on these interfaces. But more is coming, like OPC, BACnet, Siemens, S7. So these protocols are on the roadmap. I/O handling was a part of the Robustel OS so far, but not as elegant way like today. In the past, you could use SMS or email to monitor and control I/Os, but today everything goes to the cloud. You can define the type of the different input and output ports. You can set the reading interval and transmitting interval of the data. Let's go on to Modbus application. which is the most important application on the southbound part of E2C. We can say that Modbus is the leading and most popular communication protocol in automation. It's very mature and supported by millions of field devices, even new and old types. So it's very useful to have. And Modbus can be used over Ethernet, RS485, RS232. E2C is able to read and transmit the Modbus registers periodically. This period can be as low as one sec. We also can map the different registers. We can set the serial port settings, and it can collect the information via the ports. Okay. The next application we should speak about is the broker. It's the heart of E2C. It's a must-have module. So without the broker, E2C can't do anything. Its configuration is very simple. You only enable it and let it run. Almost nothing to do with it. But it's very important in the background. Of course, it offers a lot of features. Its main task is to control the data flow between the southbound and the northbound applications and store the data in the memory. Storing the data is a very important feature. It eliminates the data loss in case of cellular outage, which can happen anytime. You can store the data on flash or RAM or external memory stick or SD card. You can use a linear or a circular data storage. Broker app puts timestamp to any data. It can buffer the info, that data if it's needed. Okay, then let's move to the northbound. Northbound applications connects the routers to the IoT platforms via the WAN connection. So it's not only cellular, but WAN connectivity can be Ethernet or Wi-Fi too. So, but usually we use cellular, of course, but it can be other bearers too. So if you go take a look on the northbound apps, you can find several names, phrases which are very well known in the IT industry, in the cloud world. First, take a look at AWS, Amazon Web Services. You can find the main tab and several other tabs like Status and Certification Manager, AWS Status and Certification Manager. On the main tab, you can set up the MQTT settings for Amazon Web Services connection. Besides the MQTT, we have to upload the certificates under the Certi Manager tab. These certificates are provided by AWS. In case of AWS, we have the possibility of mass provisioning when all the field devices certificates are handled by the certificate manager of the router. It makes provisioning very fast and easy. Okay. Let's move to the Azure app. It's from Microsoft. Here you only have a few settings. Similar tabs like before, Azure Status and Certification Manager. But you can see that it's much more simple to configure Azure application. You only need to set IoT Hub device string, which is provided by Microsoft Azure. The device string contains all the necessary parameters which need to connect to MS Azure. It's more simple and very user-friendly. Besides, we have the status tab and the certificate manager, very similar like in AWS case. The third available northbound application is MQTT. Besides the specific platform applications, we have a general app, which is an MQTT application. We can set up any kind of general MQTT broker connection. So there are lots of free or not free MQTT brokers. You can use it, and you can easily configure it in the application. We have the MQTT tab where you can set the MQTT parameters, the status, and the certification. manager. So similar like the other broadband applications. Yes. Okay. These are the architecture and the modules of E2C, but where is it going? What is the future? We have a roadmap to integrate more protocols on north and southbound side. On the platform side, we will have RDMS integration, which is the IoT platform of Robustel and will be available soon. And Robustel is working on the spark plug integration. On the southbound side, we will have Backnet and Siemens S7 very soon. What should you do if you would like to start with D2C? It's very easy. If you would like to start testing, prototyping with E2C, then you only need to have an E2C starter kit, which includes all the necessary hardware and software components which is needed to start to work. Contains routers, antennas, power supply, AVS, MQTT, RCMS accounts, user guides, and application guides. All of them are pre-installed and pre-configured by us. So we will do this for you. Of course, you can configure them, but we can do it for you to make your life easy. You have no need to configure anything. It's ready to use. If you need a starter kit, then do not hesitate to contact me. We can deliver it in some days. Good. Okay, so that's all for today. You can find my contact at the end of this presentation. Here's my email and my phone number. Thanks for your time. Thanks for your interest. Let's work together and make a try with E2C, go on the E2C road. Thank you. Goodbye.